Good morning students. So the next topic is electronic configuration. What do you mean by electronic configuration? It is the distribution of electrons in various shells in an atom in such a way as to achieve the maximum stability for the atom. Okay. So how the electrons are distributed in various shells of an atom? It was suggested by the scientists Bose and Berry, and that's why it is called as Bose-Berry scheme. So based on or according to Bose-Berry scheme, we will see that how the electrons are distributed in various cells of an atom. Okay, so there are certain rules which come under Bose-Berry scheme. So we will first see what are the rules, and following those rules how we can distribute the electrons in these cells. So in the last class only I have discussed about the various cells, their energies, and different names of the cells like orbit, energy levels, stationary states, all that things. So I will not go again to that. So while explaining I will try to recall all the things. Okay. So the first rule which come under Bose-Berry scheme is the maximum number of electrons which can be filled in different shells of an atom is given by the formula 2n square. Okay. So by using this formula 2n square, we can actually see that how many maximum electrons can be filled up in K shells, then in L shell, then in M shell, N shell, O shell, and P shell, like that. Okay. So first we will see if there is K shell. So you know K shell has got the number shell number 1. Okay. So by using this formula of 2n square, where n refers to the shell number, okay, or energy level number. As you know that shell is also called as energy level, okay, or it is also called as orbit. Okay. So if it is K shell and shell number is 1, then you can just apply the formula 2n square, where for K shell n should be equal to 1. Shell number is 1 means n is equal to 1. So 2 into 1 square, we will get 2 into 1, that is equal to 2. So maximum 2 electrons can be filled up in K shells. Okay? So in K shell, maximum 2 electrons can be accommodated. So in this way we will also see how many electrons can be filled, maximum electrons can be filled in L shell, then M shell, then 4th cell, 5th cell, 6th cell, like that. Maximum electrons can be accommodated in L shell. So you know L shell is the second shell. So here n is equal to 2. Okay. So if you use this formula 2n square, where 2 into n is 2 here in case of L shell. So 2 square, how much you will get? 2 into 4, which is equal to 8. So total of 8 electrons can be accommodated in L shell. Understood? Now we will see for the next shell, that is M shell, which is cell number 3. Okay. So M shell, where n is equal to 3. So we will get 2 into 9, that is 18. So maximum of 18 electrons can be accommodated in shell number 3, that is in M shell. Okay. Next is N, which is N shell, which is shell number 4. N shell is shell number 4, so here N is equal to 4. Okay, so applying this formula of 2n square, you will get the number of electrons. How much? 32. So there are maximum of 32 electrons which can be accommodated in N shell. Similarly, we can see for the next shell number, that is 5th shell, O shell. O shell where N is equal to 5, and here we will see 2 into. So you can see here total of 50 electrons can be accumulated in O shell. Likewise, you can, by using this formula of 2n square, you can predict or calculate the total number of or maximum number of electrons which can be accommodated in P shell and other successive higher energy levels. Okay, but the second rule tells us that though the maximum number of electrons are 18, 32, 50 like that in different shell, but at a time a shell can fill up only 8 electrons. Okay, so only 8 electrons can be filled up at a time in a shell. Though it contains it can accommodate a total of 18 electrons in N shell, then 32 electrons in N shell, and 50 electrons in O shell, and then some higher electrons in P shell. But at a time a shell can accommodate total of 8 electrons in it. Understood? This is the second rule which come under Borsberry scheme. The third rule, electrons are not filled in a given shell until and unless the inner shell has got filled up. Okay? So first inner shell electrons are filled up, and after filling maximum electrons to the inner shell, the other electrons are filled up in the higher shell. So we can say that the electrons are filled up in a stepwise manner, that is from lower energy level to higher energy level. Which is the lower energy level? As the energy level or the cell which is closest to the nucleus of an atom have the lowest energy level, that is K shell, which has the lowest or the least energy, and it is called as the lowest energy. Now as you go far from the nucleus, the energy of the energy level keeps on increasing. So K shell will have the least energy, then L shell will have the higher energy than K shell, then M shell will have still higher energy than K and L shell, then N shell will have again the higher energy than K, L, M, like that. So as you go away from nucleus, that is as the cell number increases, the energy of the shell also increases. Okay, it is from 1, 2, 3, 4, 5, 6 like that. Understood? So until and unless the inner orbital electrons are not filled up, you cannot fill the electrons in higher energy levels. Okay, so maximum of, except K shell, maximum of 8 electrons if it is filled up in L shell, then only you can fill the left electrons in M shell, like that. And similarly in M shell, when total of 8 electrons are filled up, and if there is a remaining electrons, then that electrons will be filled up in the higher energy level, that is in N shell, like that. So these are the certain rules which come under Borsberry scheme, and accordingly we have to distribute the electrons according to the rules which come under the Borsberry scheme. Okay, so we will see now the electronic distribution of an atom, of different atoms. So we will start with now we will see the electronic configuration of different elements, okay, atoms of different elements. So we will see now the distribution of electrons in different shell of an atom. So we will first see the hydrogen. atom. ठीक है, element hydrogen. ठीक है. So what is the symbol of hydrogen? It is H. You can symbolize hydrogen atom as H. ठीक है. And how many protons are there, or protons are number of electrons are there in hydrogen atom? There is one proton or one electron present in one hydrogen atom. Okay, so we will see how one electron which can be distributed, okay, in the hydrogen atom. Okay, so since one electron, so it will take the place in K shell, which is the first shell. It is the first shell, ठीक है, of an atom. It is the shell with the lowest energy, closest to the nucleus. ठीक है. So first K shell in K shell one electron of hydrogen will be filled up. So you can write the electronic configuration as 1. Okay, so in K shell there is one electron which is filled up. ठीक है. So now we will see in the second atom of the next element, that is helium. Okay, so helium, you can symbolize helium atom as He, and number of electrons in helium atom are 2. ठीक है. So how will you distribute 2 electrons? This is the nucleus and this is your K shell. So 2 electrons will be accommodated in the K shell only. As you know that maximum number of electrons K shell can accommodate is 2 electrons. ठीक है. So these 2 electrons of helium will accommodate K shell only. Okay, so we will write the electronic configuration as 2 in K shell. Okay, so electronic configuration of helium will be 2. Okay, in K shell. Now the third atom of the next element, that is lithium. So you can symbolize lithium as Li, and there are 3 electrons present in an atom of lithium element. Okay, so how will you distribute these 3 electrons? As you know that this is the K shell, if this is the nucleus and this is the first shell, it is K shell, and you know that in K shell only maximum of 2 electrons can be filled or can be accommodated. So out of 3, 2 electrons will take the place in K shell, and rest 1 electron will come to the higher shell, that is L shell. Okay, so how the electrons are distributed? 2 electrons in K shell and 1 electron in L shell. Okay, so electronic configuration will be 2, 1. 2 in K shell and 1 in L shell. So total of 3 electrons we have distributed. Okay, in lithium atom. Now the next atom is beryllium atom. You can symbolize beryllium as Be, and electrons present in an atom of beryllium are 4 electrons. Okay, so here also 2 electrons will take place in K shell, that is first shell, and other 2 electrons will take the place in L shell. Okay, as you know that in L shell you can accommodate maximum of 8 electrons. Okay, so we have distributed the left 2 electrons in L shell. So the electronic configuration will be 2 and 2. 2 electrons in K shell and other 2 electrons in L shell. Now you can see that now L shell is getting filled up. And now so electrons are getting filled up in shell number 2, that is in L shell. Okay? So L shell can accommodate the maximum electrons of 8. Okay, so we will see the next atom, that is boron atom. Symbol of boron atom is B, and there are 5 electrons present in boron atom. So likewise you can distribute 1, 2, 2 electrons in K shell and again 3 electrons in L shell. So you need not have to draw the next energy level. Okay? So 3 electrons in L shell and 2 electrons in K shell. So like that you can write the electronic configuration as 2 and 3, where 2 is in K shell and 3 electrons in L shell. Understood? Then next one, carbon. Can symbolize carbon as C, you know very well. And there are 6 electrons present in an atom of carbon. Okay. So here also we did not draw the N shell. Here the 2 electrons will be accommodated in K shell and other 4 electrons out of 6 will be accommodated in L shell. So here also electronic configuration will be 2 in K shell and 4 in L shell. So electronic configuration will be 2 and 2, 4. Understood? Next comes nitrogen atom. Okay, nitrogen symbol is N. Okay, and there are 7 electrons present in an atom of nitrogen. So here also 2 electrons will be accommodated in K shell and left 5 electrons. Okay, there are 7 electrons now. So left 5 electrons. So total of how many electrons we have? Whole 7 electrons we have distributed. 1, 2, 3, 4, 5, 6 and 7. Okay, 2 electrons in K shell and other 5 electrons in L shell. So likewise you can write the electronic configuration as 2 and 5, where 2 will be in the K shell and L will be there will be 5 electrons. So likewise you can write the electronic configuration. Now we will go to the next atom, that is now we will see oxygen atom. Symbol of oxygen is O. Okay, and there are 8 electrons in an oxygen atom. Okay, so how will you distribute 8 electrons? We will distribute 2 electrons in K shell and other 6 electrons 2, 3, 4, 5, 6 in L shell. Okay, so electronic configuration will be 2 and 6. Understood? 2 in K shell and 6 in L shell, like that. Okay, next atom is fluorine. Symbol of fluorine is F and there are 9 electrons in an atom of fluorine. Okay, so how will you distribute? Again 2 electrons in K shell and other 7 electrons 3, 4, 5, 6 and 7 in L. The total of 9 electrons we have distributed 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so in K shell you have 2 electrons, in L shell you have 7 electrons. So total 2 and 7, 9 electrons have been distributed in K and L shell. Okay, so next is neon atom. Its symbol is Ne and there are 10 electrons present in an atom of neon. So here you will see that the outermost orbit, that is L shell. L shell is the outermost orbit. Why? Because this is the outer shell. Okay? There are 2 shells only, K and L shell, where you can say K is the inner shell and L is the outermost shell. Okay, of neon atom. So 2 electrons we have distributed in K shell and other 3, 4, 5, 6, 7 and 8 electrons in L shell. So here you can see that L shell is now completely filled. Okay, why it is completely filled? As you know that in second shell or in L shell there are maximum of 8 electrons can be accommodated, and 8 already we have filled up in L shell. So we can say that here the neon atom has octet of structure. So these things I will define later also, but let me just introduce this term octet. Octet means what? Octet means if any atom have the octet of structure, it is possessing the octet structure, that means its valence shell or its outermost shell is completely filled, that is with 8 electrons, except K shell. K shell maximum of 2 electrons only can fill up, where in other L, M, N and other higher energy level and higher shells, maximum of 8 electrons can be filled up. And if the outermost shell is completely filled up, that is with 8 electrons, we can say that that atom is having the octet of structure. So we can say that neon is having the octet of structure, and you will be knowing that it is one of the inert gas elements, okay, which is highly unreactive. Okay, it doesn't show the chemical reactivity Okay. So here also we can just see the electronic configuration 2 and 8. 2 in K shell and in L there are 8 electrons. Okay. So now when we go to the sodium atom, whose symbol is Na, and there are 11 electrons present in an atom of sodium. So here, because in the previous atom L shell is completely filled, so in the next atom, that is in sodium atom, you have to draw one more shell, that is the higher shell than L, that is M shell. So, okay. Since there are 11 electrons, so 2 will be filled in K shell, another 8 will be filled in L shell. Okay, 1, 2, 3, 4, 5, 6, 7 and 8. Okay. So 2 plus 8, 10. Still one electron is remaining, which will go to the higher level, that is in M shell. It will not be filled in L shell. Why? Because, you know students, because in L shell you can only accommodate maximum of 8 electrons. That is already filled up. Okay, so for one more electron which is remaining, it will go to the higher energy level or higher shell, and which is the higher shell, that is M shell. That's why I have drawn here the next energy level, that is the M energy level, and I have accommodated the left one electron in M shell. So how you can write the electronic configuration here? 2 electrons in K shell, then 8 electrons in L shell and 1 electron in M shell. So electronic configuration will be shown like that: 2, 8, 1. Okay, 2 in K shell, 8 in L shell and 1 electron in M shell. Understood? Okay. Now next is the magnesium atom. Its chemical symbol is Mg, and there are 12 electrons in an atom of magnesium. Okay. So 2 electrons will be distributed in K shell. Then another 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8 in L shell. Total 10 have been distributed. Now left 2 electrons will go to M shell. Understood? So electronic configuration will be 2 in K shell, 8 in L shell and remaining 2 in M shell. 2, 8, 2 will be the electronic configuration of magnesium. Okay. The next is aluminium. Symbol is Al, and there are 13 electrons. So 2 in K shell, 1, 2, 3, 4, 5, 6, 7, 8. Again 8 electrons in L shell and remaining 3 electrons in M shell. So electronic configuration will be 2, 8 and 3. Okay. As you see successively stepwise, now the M shell is getting filled up with the electrons. Now in silicon, chemical symbol is Si. There are 14 electrons. So same thing, 2 electrons in K shell, 8 electrons in L shell and 1, 2, 3, 4, 5, 6, sorry. So how many? 14 no? So 1, 2, 3, 4. 4 electrons will go to M shell. Okay. So electronic configuration will be 2, 8 and 4. In phosphorus atom, there are 15 electrons present in an atom of phosphorus. So how you can distribute the electrons? 2 electrons in K shell, 8 electrons in L shell and remaining 5 electrons in M shell. So electronic configuration will be 2, 8 and 5. Okay. Then next comes sulfur. Sulfur can be denoted as S, and there are 16 electrons in sulfur atom, and here you can see 2 electrons in K shell, 8 electrons in L shell and rest 6 electrons in M shell. So 2, 8, 6 will be the electronic configuration of sulfur. Chlorine, its symbol is Cl, and there are 17 electrons present in an atom of chlorine. So here also you can do the same thing. In K you have 2 electrons, okay, then 8 electrons in L, and rest 7 electrons. Okay, 1, 2, 3, 4, 5, 6, 7 electrons in M shell. So electronic configuration will be 2 in K, 8 in L shell and 7 in M shell. Okay. So argon, as you can see here, there are 18 electrons present in it. Symbol is Ar, and here you can see the M shell is getting completely filled. 2 in K shell, now 8 in L shell, and again the remaining electrons, that is 8 electrons, will be filled up in M shell. So here in argon also you can see the outermost orbit is getting completely filled, that is with 8 electrons. So here also we can say argon have the argon has the octet structure. It possesses the octet structure because its outermost orbit is completely filled with exactly 8 electrons. So here you can see the electronic configuration is 2, 8 and 8. M shell is completely filled. And if you remember, argon is also one of the inert gas elements and it is also highly unreactive. Okay. Now next comes potassium. There are 19 electrons in an atom of potassium. So here also you can see there are 2 electrons in K shell, 8 electrons in L shell. Okay. And since M shell is also got filled up with 8 electrons, 1, 2, 3, 4, 5, 6, 7 and 5, 6, 7 and 8. So we will draw one more shell, that is N shell. So after M which shell comes? N shell. So here how many remaining electrons are there? 1 electron. So 1 electron will go in the higher shell, that is N shell, after M. Okay. So what will be the electronic configuration? 2, 8, 8 and 1. 2 in K shell, 8 in L shell, again 8 in N shell and remaining 1 in N shell, in the higher orbit, that is higher shell, that is N shell. Okay. Now in calcium, the calcium can be denoted as Ca and its electrons are 20 in number. So likewise 2 electrons in K shell. Okay. Then 8 electrons in L shell, that is 10 electrons, again 8 electrons in M shell, so total 18 electrons. You have 20. So rest 2 will go to the higher orbit, that is N shell. So the electronic configuration will be 2, 8, 8 and 2. Okay. So just like that you can distribute the electrons in different shell, or you can show the electronic configuration by making use of Borsbury scheme. And I have already discussed all the three or four rules which come under Borsbury scheme. Okay, so during this electronic configuration, we also came through various terms like octet, valence shell, then valence electron, etc. Okay, so let me just introduce to you about these terms. What is valence shell? What do you mean by valence shell? Valence shell is nothing but the outermost shell of an atom. Okay. So if you see phosphorus, what is the outermost shell? Here M shell is the outermost shell, as you can see. Okay. Innermost is K shell and outermost is M shell. So outermost shell is called as the valence shell. So if in the question it is asked what is the valence shell in the atom of phosphorus, we will write M shell is the valence shell in the atom of phosphorus. What about sulfur? In sulfur also the outermost shell or the valence shell is M shell. Okay. So the next is valence electrons. Okay. Valence electrons are called as actually outermost electrons. Okay. So you can define valence electrons as electrons which are present in the outermost shell, or electrons which are present in the valence shell. Valence shell and outermost shell both are same. So valence electrons are the electrons which is present in the valence shell, okay, of an atom. So what is the valence shell in fluorine? It is the M shell. And how many electrons are there in valence shell? That is in M shell. 1, 2, 3, 4, 5, 6, 7. So if it is asked how many valence electrons are there in an atom of fluorine, you will write there are 7 electrons present in the 7 valence electrons there in fluorine atom. Understood? So valence electrons are the electrons which is present in the valence shell, that is in the outermost shell. Okay, in sulfur how many valence electrons are there? 1. This is the valence shell, and electrons there are 1, 2, 3, 4, 5 and 6. So there are 6 valence electrons in sulfur atom. Okay. Now this term also we came through octet. As I told you, in an atom, if the valence shell is completely filled with 8 electrons, we will say that atom of an element possesses the octet structure. Okay. So here you can see how many electrons are there here. 1, 2, 3, 4, 5, 6, 7. And in this 1, 2, 3, 4, 5, 6, 7 and 8. So here if the 8 electrons are there in M shell that we saw in argon, so we can say that argon has the octet of structure because its valence shell is completely filled with 8 electrons. So you should remember all these 3 terms. Okay.